Have you ever just thought about how we get these machines to do what we want? I mean, how does a simple idea in your head turn into an app on your phone? That's exactly the journey we're going to take today, from a human idea all the way to our very first program, Hello World.
And really, it all boils down to this one question. How do we bridge the gap between our creative, kind of messy human brains and the super literal, logical world of a computer? Well, that bridge has a name, and it's called programming.
You know, when you strip away all the jargon, that's all programming is. It's the art of writing a set of instructions that are so clear, so precise, that two totally different things can understand them. You, the smart, problem-solving human, and the machine, which is incredibly powerful but also needs to be told exactly what to do.
So, here's our game plan. We're going to start with what programming really is. Then, we'll jump right in and look at the famous Hello World program. After that, we'll decode its language, break down its basic parts, and finally, see how that simple piece of text actually comes to life.
All right, first up, what even is programming? See, before you can start giving instructions, you have to decide on a language you're both going to speak.
And there's a whole spectrum of these languages. On one end, you have low-level languages. They're super close to the raw ones and zeros the computer actually thinks in. They're fast, they're powerful, but honestly, they look like gibberish to most of us. On the other end, you have high-level languages, like Java. They're designed to be way closer to how we humans talk, which makes them a whole lot easier to write and to understand.
Okay, section 2. We're going to do this a little backwards. Instead of starting from scratch, let's just jump to the finish line and look at the final product. This is the classic first program everybody writes. It's called Hello World. Now, I know what you're probably thinking. Whoa, what is all that? It looks pretty cryptic, right? And you're not wrong. But trust me on this. By the time we're done here, every single piece of this is going to make perfect sense. This is our target.
All right, time to start decoding. You see, just like English or Spanish, programming languages have their own rules, their own grammar and vocabulary. So let's break down the basics for Java. The main rules are actually pretty simple. First, the name you give your file has to be exactly the same as what's called the public class inside. So for us, that's helloworld.java. Second, see that semicolon? Think of it like a period at the end of a sentence. It tells the computer, okay, that instruction is finished. And finally, every Java program has to have a front door, a place where it all begins. That's called the main method.
Now let's talk about keywords. These are special, reserved words that are part of the Java language itself. They have built-in superpowers, which means you can't use them as names for your own stuff. They're like the fundamental verbs and nouns of this new language we're learning.
And here are some of them. You already saw a few in our example, like public and class. There are others like if, for, while. These are the core commands you use to build logic. Don't worry about memorizing them all. Just know that these are the special tools in your programming toolkit. Oh, and one more quick thing about the language. Comments. These are basically just notes that you leave for yourself or for other people reading your code. You can write anything you want in a comment, and the computer just completely skips over it. They're super important for keeping your code easy to understand.
Okay, so we've got the basic grammar down. But how do programs actually do anything with information? Well, let's talk about the basic building blocks for storing and using data.
The most fundamental block of all is the variable. A program needs a way to remember things while it's running, right? Like a score in a game or a user's name. A variable is just a named bucket in the computer's memory. The labeled box idea is perfect. You give a box a name, and then you can put something inside it.
But here's a little twist with Java. It's what we call strongly typed, which means you can't just throw anything you want into any box. Every single variable, every box, has to declare what type of information it's allowed to hold. This is what we call a data type. It's like telling the computer, hey, this box is only for whole numbers, or this box is only for text.
And here are a few of the most common types you'll see. You have int for integers, whole numbers. Then double for when you need decimal points. A Boolean is super simple. It can only ever be true or false. That's it. And a char is for holding just a single letter or symbol. This whole system helps prevent a ton of mistakes before they even happen.
So we have the rules of the language, and we have the boxes to store our information. Now for the final piece of the puzzle. How does the simple text file you wrote actually come to life and run on your machine?
Well, it's a three-step dance. First, you edit your code. That's just you typing in a text file. Second, you compile.
A special program called a compiler checks your grammar and translates your code into an intermediate language called bytecodes. Finally, you execute. A different program, called an interpreter, reads those bytecodes and translates them line by line into instructions your computer's processor can finally understand.
And to make this all work, you need the right tools. The JDK, or Java Development Kit, is the whole workshop. It's what programmers use to write and compile the code. But if you just want to run a Java program, all you need is the JRE, the runtime environment. And at the heart of it all is the JVM, the Java Virtual Machine. That's the engine, the interpreter, that does the final step of actually running your code.
Of course, sometimes things go wrong. A compile time error is basically a grammar mistake. You forgot a semicolon or misspell the keyword. The compiler is great because it finds these for you before you even try to run the program. A runtime error is sneakier. Your grammar is perfect, but your logic is flawed, like telling the computer to divide a number by 0. Those errors only pop up when the program is already running.
So, let's look at this one last time. It's not so intimidating now, is it? You can actually see the pieces. You see the keywords, public and class. You recognize the main method as the program's front door. And you see that one single instruction, ending in a semicolon, that tells the system to print Hello World out to the screen.
And that's it. That's the magic trick. With just a few lines of code, following a very specific set of rules, you created a perfect step-by-step recipe. You literally just told the computer exactly how to say its first words to the world.
So now you get the basic journey, from a text file to a running program. But, in the world of tech, there's always another layer to peel back. We talked about compiling first, then interpreting. But what if you could do both at the same time? That leaves us with a pretty cool question. What in the world is a just-in-time, or JIT compiler?
We'll have to save that one for another day. If you enjoyed this explainer and things are starting to click, do me a favor and hit that like button, share it with someone else who's curious about this stuff, and of course, subscribe to Tech Talk 101 for more explainers that break down the tech shaping our world. Thanks for tuning in.